Morning students, so today we'll see a portal frame. So in last two classes we saw continuous beams. So today we'll see a portal frame. So this is a portal frame in the shape of a L, inverted L I should say sorry. And you have to analyze by strain energy method. So let us have a closer look. See, AB has I, whereas BC has two I's. So I is changing, so that you have to remember. Always go through the problem once or twice, go to the question. Then only you know what is given, what has to be found out. So here we are going to find the bending moment. And the load is acting only on the column BC. Okay, at D it is 40 kilonewton and the central point load. AB does not have any load. Okay. So as usual, strain energy method, you have to first find the SI. So for beams, number of equilibrium equations small r equal to 2 only. Summation V equal to 0 and summation M equal to 0. For portal frame it is 3. You have to also include summation H equal to 0. Summation V equal to 0, summation H equal to 0 and summation M equal to 0. So 3, see here it is 3, minus 3 smaller. And capital R, let us see, it has two supports. A has a fixed support, so 3 reactions. And C has a hinge support, 2 reactions. So 3 plus 2, see 3 plus 2, 5 given here. So 5 minus 3 is 2. So you have 2 redundant forces. Because of 2 forces, the portal frame has become indeterminate. If you remove two redundant forces, it become determinate. That is what I have given here. So see here, at C you have two forces, 2 reactions, VC and HC. So if you remove both these reactions, so it will become like a cantilever beam. See, only A is fixed, so it will become like a cantilever beam. So portal frame you can unfold it and see it as a beam. So now it has become a cantilever beam which is determinate. Okay. So VC and HC are the redundant forces, and now strain energy method, dou U by dou the redundant force, two redundant, dou HC equal to 0 and dou U by dou VC equal to 0. So that is 1 by A. This is the real formula. Bending moment M into dou M by dou HC into dx equal to 0 and dou M by dou VC dx equal to 0. Now strain energy method, again you have to say, take sections. So similar to last problem, we'll have two sections for the portion BC. Why? Because it has one point load. So before the point load one section, origin is from C only, and after the point load one section, which is after the point load. Okay. So redundant forces, and AB will have one section, will have the section from B. Okay, X from B for AB. So origin BA portion from B, limit 0 to 4. So it can have only the distance from 0 to 4, that is the maximum distance. And bending moment, what will be the bending moment for at X? What are the forces acting? VC, HC and 40. So 2 reactions and 40 kilonewton. So yeah, so I'll draw. So VC, I mark VC and the section X separately. See, so how do you calculate the bending moment or bending moment? What you have to do, you have to draw a line parallel at X to the load. So this is the load, right? So parallel to this, you have to draw a line at the X section, and the distance, that is moment is load into distance. So distance is the distance. The distance between these two parallel lines is the required distance. Okay. So VC into X. Okay, you understand. Now again the second force is 40. The second force is 40. It is acting horizontally on the portion BC. Now this is X. Yeah, this is X. So what you have to do again? The line of action of force is horizontal. Parallel to that, you have to draw a line at X. So distance between these two is the required distance. So 40 into 3. Okay. So VC into X, I explained you. This is 40 into 3. And again you have HC. HC again, if you draw a parallel line, I hope you understand. Same thing only. It is also horizontal. So this is X. So draw a parallel line. So distance is 6 meters between HC and X. So that is what is given. So the bending moment, VC into X, minus 40, all the horizontal force will have it as negative. So upward force positive. So VC into X, minus 40 into 3, minus HC into 6. So now you have to differentiate this with respect to HC. So only term which HC is 6. So you'll have only minus 6. Other things 0. And high is I naught. So this is a table. So similarly you can have for CD and DB. CD origin CC. So 0 to 3. CD can only have 0 to 3. So 0 to 3, see, 0 to 3 and 3 to 6 for the next portion dB. Okay. So this is what we did in the previous one. And for x is from CD, from C to D. One second. Kindly adjust. Okay. So x is from C. So this is HC. So HC is here, x is here. So you draw a parallel line. So distance between these two lines is x. So HC into x for the portion CD. Next for next for DB portion, x is here, x is somewhere here. So for HC it is HC into x only. VC is acting on the same line, so 0. So the line of action of the force x, if you can't draw parallel line, it is coinciding, so distance 0. And for 40, so this is 40. This is 40 kilonewton. Draw a parallel line at x to this. What is the required distance? This one. So what is this distance? Total is x. This is 3. So x minus 3. So that is what is given. Okay, just go through the video again. If you have any doubts, you ask me. So now dou m by dou hc. So whatever hc term, so minus x. So here also minus x. And you also need to do dou m by dou vc. So x 0 0 and I values. So now what is the real purpose? So this formula. So first you have to do m into dou m by dou x, hc into dx, and then you have to integrate. Similarly, m into dou m by dou vc into dx. So I have done that. See, I have taken one portion. Okay. So portion AB, 1 by A, take it outside. So VCX. So this is moment. VCX minus 6 HC minus 120 into minus x. So I have solved it. See, this into that. So this into this. Like next for portion BD, this into this. Just have to multiply, and I have just solved. You'll understand. Okay, you have to solve it by yourself and see. There's nothing to explain. Simply for portion CD and portion DB. Okay, and it is very easy for. And then you have to add all the portions A, B, CD, and DB. You'll get this equation, first equation. In terms of VC and HC, two unknowns. Again, you need another one equation. Two unknowns you need to solve. If you need to solve two unknowns, you need two equations. So again, for the next one, it is very easy. Why? So come to the table. Because see, dou m by dou vc for portion BD and the other portion is 0. So one second. See, for portion CD and DB, when there is only HC, no VC. When you differentiate with respect to VC, it has become 0. So anything into 0 is 0. So you need to only multiply this value m into x only. So this value into x only will be multiplied, other portions will be 0. So that has become easy for the second one. Okay. So we are going to complete the problem. Okay. So two unknowns, two equations, first equation, second equation, two equations, two unknowns. We solve, you get the value of VC, and then after getting the values, you have to apply in the moment. So moment for AB is this value you have in the table. Simplify, have the values of HC and VC. Then you apply the limit 0 to 4. Similarly, do for the other things also. For portion CD and for portion CD, have the values. Then you can have for portion DB, and you will draw the bending moment diagram. Bending moment diagram, whoever came to the college, I taught them. Girls, you came, but you were not able to spend time with me. So come on Friday. Okay, Friday we are arranging a bus from Rajapalayam. So all of you come. We'll have a regular class and lab also. Okay. Okay. Thank you guys. Put your attendance and attend the quiz also. I'll put it shortly. Okay. When I reach college. Now for the time being, watch the video and put the attendance. Thank you.